Hi guys, so today we're going to be doing tests for parallelograms. Okay. Basically, previously we learned about the properties of parallelograms, and now we're going to use those properties to prove that when we see certain quadrilaterals that they are parallelograms as long as they have those properties. Okay. So that brings us to some of our corollaries or our converses to prove parallelograms. So if we know that both pairs of opposite sides of a quadrilateral are congruent, then that quadrilateral is going to be a parallelogram. So if we know that this is congruent to this and this is congruent to this, it makes it a parallelogram. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if this and this is congruent and this is congruent, it's going to be a parallelogram. Okay. If the diagonals bisect each other, then it's a parallelogram as well. So if this is congruent to this and this is congruent to this, if they're divided in half. Right. If we know that one pair of opposite sides of a quadrilateral is both parallel and congruent, then that quadrilateral is going to be a parallelogram as well. Okay, so that's a nice summary from page 334, as well as on page 335. This just summarizes basically those exact same theorems. Okay. So that takes us to example 1. So rather than writing it all out for you, I'm just going to use it in the book and then point and explain what it means. So here we're writing a paragraph proof for theorem 6.10. Again, you cannot call it that because that really has no meaning in the real geometry or math world. What it wants us to prove, it wants us to prove that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay? So that's where we're starting off with our given. We're using this picture to kind of help explain it. Okay? So we are given that angle A and angle C are congruent, and angle B and angle D is congruent. Okay? Because of the axiom that tells us that any 2 points determine a line, we can draw segment AC connecting point A and point C. As a result, we now have 2 triangles. We know that the sum of the angle measures of a triangle is 180. Okay? So the sum of the angle measures of these 2 triangles is 360, which is why measure of angle A, B, C, and D together equal 360. We saw that previously with our interior angle sum theorem. That's where we got that idea. Since angle A is congruent to angle C and angle B is congruent to angle D, we had that in our given. That means that their measures are also the same. Okay? So what we can do is we can substitute to find that the measure of angle A plus the measure of angle A and the measure of angle B plus the measure of angle B equals 360. So basically what happened is we replaced this with a measure of angle B and we replaced this with a measure of angle A. Okay. Another way to say it is that 2 of our measure of angle A's plus 2 of our measure of angle B's equals 360. And then dividing each side of them tells us that measure of angle A plus measure of angle B then is 180, right? Because divide by 2 on both sides. Okay. And what that means then is that angle A here and angle B are supplementary. Okay. And since they are consecutive angles or same side interior angles that are supplementary, then we know that AD here is parallel to BC. Okay. Likewise, we can do the exact same thing, right, with angle A and angle D to be 360, which means 2 of them each would equal 360. That means measure of angle A plus measure of angle D is 180, okay, which means these 2 are supplementary. So using the exact same thing of consecutive interior angles, then this proves that AB is parallel to DC. And as a result, since opposite sides are parallel, ABCD is a parallelogram. There you go. Okay. So why don't you try check your progress? You're going to write a 2-column proof for theorem 6.12, which states that if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. Okay, you should have gotten something along this line. So drew a picture, labeled the vertices, right? A, B, C, D. I know because of what I'm given that AB is congruent to DC, and they're also parallel to each other, and I want to prove that this is a parallelogram. So I start out with my given. Then the second thing I drew is I drew a diagonal AC, and I can do that because 2 points determine a line. Okay. Then, as a result, I know that angle 1 is congruent to angle 2 because of the alternate interior angles theorem, right? Parallel lines cut by a transversal, the alternate interior angles are congruent. Then AC is congruent to AC because of the reflexive property, something always equals itself. And as a result, then I can state that these two triangles that I divided it into are congruent because of side angle side postulate, right? Side angle and then that side. Okay. Then, as a result, I can say that AD is congruent to BC because if the triangles are congruent, then corresponding parts of the congruent triangles have to be congruent. Okay. And then after that, then ABCD then has to be a parallelogram because if both pairs of the opposite sides are congruent, right? AB is congruent to DC that was given to us, and now using CPCTC, I just proved that AD is congruent to BC. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. And there you go. Okay, then the next one is example 2. And then I'm going to just show it from the book then, so I don't have to write it all out. So here, some panels in the sculpture here, appear to be parallelograms. Right? Describe the information needed to determine whether these panels are parallelograms. So really, it's just what are the properties of a parallelogram that make them special, right? So one thing we should know is that both pairs of opposite sides are congruent. Then it is a parallelogram. Or if the opposite side is congruent and parallel, if one of them is. Okay. We also know that the diagonals bisect each other. We know that also both pairs of opposite angles are congruent, then those panels are parallelogram. If it meets some of these requirements that we saw here, that proves that it's a parallelogram. Okay. So that was nice and easy. It's just reviewing, do you know the properties of a parallelogram? Okay. So that takes us to CYP2. Tiffany has several pieces of tile that she's planning to make into a mosaic. How can she tell if the quadrilaterals are parallelograms? Okay, so this one's also just asking you again about the properties of a parallelogram. So if both pairs of opposite sides are congruent, that's a parallelogram. The quadrilateral will be a parallelogram. If both pairs of opposite angles are congruent, then that quadrilateral is a parallelogram. If the diagonals bisect each other, that quadrilateral is a parallelogram. Or if one pair of the opposite sides are both parallel and congruent, then that quadrilateral is a parallelogram. Okay. So our next example is example 3. We're going to determine whether the quadrilateral is a parallelogram, and we're going to justify our answer. Okay. So here, I see that opposite angles are congruent. So that means that this is a parallelogram. Parallelogram. And my reasoning, both pairs of opposite angles are congruent. And there you go. Okay. So why don't you try CYP3, determine if this is a parallelogram, and then once you got it, you're good. This is a parallelogram because one pair of opposite sides are parallel and congruent. You might be wondering, I see how they're congruent, but why are they parallel? The reason why this line and this line are parallel is because alternate interior angles are congruent, right? And so our converse of our alternate interior angles theorem tells us that if alternate interior angles are congruent, then those lines that form it have to be parallel. Okay, so then next is example 4, find x and y so that the quadrilateral is a parallelogram. So we know that for a parallelogram, the opposite sides are congruent, so that means 6x minus 12 equals 2x plus 36. And we know that 4y equals 6y minus 42. So I'm going to move the x's to one side, so subtract 2x. This gives me 4x minus 12 equals 36. Add 12 to both sides. This is 4x equals 48. Divide 4 on both sides, x equals 12. Then solving for y, subtract 6y so that the y's are together. So negative 2y equals negative 42. Divide both sides by negative 2, y equals 21. And so my two answers is x equals 12 and y equals 21. So then, why don't you try out 4a and 4b, and then once you're done, come check your answer. Okay, for 4a, you should have gotten x equals 8, y equals 30, and for 4b, you should have gotten x equals 3, y equals 7. If you got that right, you can move on to our last example. If not, here is your explanation. So 4a is using the theorem or the property of a parallelogram that opposite angles are congruent. And so that's why 56 equals 7x, and 5y minus 26 equals 4y plus 4. Okay. To solve for x, divide by 7 on both sides, x equals 8. To solve for y, I put the y's together, so subtract 4y on both sides, that gives me y here. And then add 26 to the other side, that gives me 30. Okay. For b is using this the property that opposite sides of a parallelogram are congruent. So that's why 3x plus 4 equals 5x minus 2, and 4y minus 9 equals 2y plus 5. So I move the 3x over by subtracting 3x, that gives me the 2x here. Add 2 to the other side, that gives me 6. Divide by 2, x equals 3. Move the y over by subtracting 2y, that gives me 2y here. Add the 9 to the other side, that gives me 14, and divide by 2 on both sides, that gives me y equals 7. Okay. So then the last part here, we're going to determine whether the figure with these vertices is a parallelogram, and this time we're going to be using the slope formula. Okay, so let's graph it. So A is 3, 3, so 1, 2, 3, 1, 2, 3, here's A. B is at 8, 2, so 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, here's B. C is at 6, -1, so 1, 2, 3, 4, 5, 6, 1, here's C. And D is at 1, 0, so here's D. And then just so that way it's a little bit easier to see, I'm going to pink pen here. And then here, you can use the slope formula, or you can count it as rise over run. Right? So then, let's use a different color. So here, AD, I'm going up 1, 2, 3 over 2. So AD here is 3/2. Okay. AB here, I'm going down 1. So that's negative. Right 1, 2, 3, 4, 5. So AB down 1 makes it negative. Right is positive, so negative 1/5. Then I'm doing CB here. Okay. So I'm going up 1, 2, 3, right 2. So this is 3/2. And then DC here. Down 1, right 1, 2, 3, 4, 5. So negative 1/5. So what that means is that from this, I know that AD is parallel to BC or CB, and that AB is parallel to DC. And so, since opposite sides are parallel, both pairs of opposite sides are parallel, this is a parallelogram. Both pairs of opposite sides are parallel. And there you go. Okay, so why don't you try CYP5 this time instead of using the slope formula, you're using the midpoint formula to prove that to see if it's a parallelogram. Okay, they are not, this is not a parallelogram. Using the midpoint formula, we know that one of the properties of a parallelogram is that the diagonals bisect each other, right? And so their midpoints should be the same. However, when I find the midpoint of FH and the midpoint of JG, they are not the same point, which means that these diagonals don't bisect each other, so it's not a parallelogram. So that's it for today. Have a great rest of the day. Bye, guys.